Question 1. Quality control measures reveal that a newly installed commercial rainwater harvesting system has been completed. The system includes collection surfaces, conveyance piping, a storage tank, and a distribution pump. The installer has provided documentation indicating the system's intended use for landscape irrigation and toilet flushing. As a commercial plumbing inspector, which of the following actions best ensures compliance with regulatory requirements for rainwater harvesting systems? Option A. Verify that the collection surfaces are clean and free of debris, the conveyance piping is properly sloped, and the storage tank is securely installed and has an overflow outlet. Option B. Review the system's design documents for compliance with applicable plumbing codes regarding filtration, treatment, backflow prevention, and cross-connection control, and then conduct a site inspection to ensure the installation matches the approved design and meets all code requirements for materials, connections, and system components. Option C. Accept the installer's verbal confirmation that all components meet code specifications and that the system is designed to prevent contamination, as they are experienced professionals. Option D. Confirm that the storage tank is adequately sized for the expected rainfall and that the distribution pump is operational, as these are the primary functional components of the system. The correct answer is A. Verify that the collection surfaces are clean and free of debris, the conveyance piping is properly sloped, and the storage tank is securely installed and has an overflow outlet. Explanation. This scenario presents a professional challenge because it requires the inspector to balance the immediate need for a functional rainwater harvesting system with the long-term implications of its design and installation, particularly concerning public health and environmental safety. The inspector must exercise careful judgment to ensure compliance with all applicable codes and standards, preventing potential issues like water contamination, structural integrity problems, or inefficient system performance. The correct approach involves a thorough review of the system's design documents against the relevant sections of the International Plumbing Code (IPC), or the Uniform Plumbing Code (UPC), depending on the jurisdiction's adoption and any local amendments. This includes verifying that the collection surfaces, conveyance systems, storage tanks, filtration and distribution methods meet the prescribed standards for materials, sizing, overflow provisions, and backflow prevention. Specifically, the inspector must confirm that the system design incorporates adequate filtration to remove debris and contaminants before water enters the storage tank, and that the storage tank is designed to prevent the entry of vermin and unauthorized access, as well as to manage potential stagnation. Furthermore, the installation must be inspected to ensure it aligns with the approved design, and that all connections are secure and properly sealed. This approach is correct because it directly addresses the regulatory requirements for safe and effective rainwater harvesting systems, prioritizing public health and system longevity, as mandated by plumbing codes. An incorrect approach would be to approve the system based solely on the visual appearance of the installed components, without verifying their compliance with the approved design and code requirements. This fails to address potential hidden defects or non-compliance with critical aspects like filtration efficacy or tank integrity, which could lead to contaminated water or system failure, violating the public health and safety mandates of plumbing codes. Another incorrect approach is to focus only on the water collection and storage aspects, neglecting the critical downstream components such as the filtration, treatment, and distribution systems. This oversight could result in the provision of non-potable water that is unsuitable for its intended use, or worse, a system that poses a health risk due to inadequate treatment, thereby failing to meet the comprehensive requirements of plumbing codes for water systems. A further incorrect approach would be to approve the system based on the installer's assurances that it meets all requirements, without conducting an independent inspection and verification against the code. This abdicates the inspector's responsibility and relies on potentially biased information, which is a failure of professional due diligence and a violation of the inspector's ethical and regulatory obligations to ensure public safety. The professional decision-making process in such situations should involve a systematic review of all submitted documentation against the applicable codes and standards. This should be followed by a detailed site inspection, comparing the installed work to the approved plans and code requirements. Any discrepancies or potential noncompliance should be documented, and corrective actions must be required before final approval. This structured approach ensures that all aspects of the system are evaluated for safety, functionality, and adherence to regulations, thereby upholding the inspector's professional integrity and safeguarding public welfare. Question 2. Compliance review shows a plumber working in an area with visible dust and debris, not wearing safety glasses, gloves, or a respirator. The work is estimated to be about 15 minutes from completion. What is the most appropriate immediate action for the commercial plumbing inspector? Option A. Overlook the PPE violation as the work is nearly complete and the duration of exposure is minimal. Option B. Stop the work immediately and instruct the plumber to don the required personal protective equipment, PPE, before continuing. Option C. Document the violation in the inspection report but allow the plumber to finish the remaining 15 minutes of work. Option D. Inform the site supervisor of the violation and trust them to ensure the plumber uses PPE for the remainder of the task. Correct answer is B. Stop the work immediately and instruct the plumber to don the required personal protective equipment, PPE, before continuing. Explanation. Scenario analysis. This scenario is professionally challenging because it requires the inspector to balance the immediate need for safety compliance with the practical realities of a construction site. Inspectors must ensure adherence to regulations without unduly hindering progress, demanding a nuanced understanding of both the law and site operations. The inspector's judgment is critical in determining if a deviation from standard PPE use poses an unacceptable risk or is a minor, easily correctable issue. Correct approach analysis. The correct approach involves a direct, professional intervention to ensure immediate compliance with safety regulations. This aligns with the inspector's primary responsibility to uphold the Commercial Plumbing Inspector Certification exams governing regulations, which mandate the use of appropriate personal protective equipment, PPE, to prevent injuries. Specifically, regulations require eye protection, gloves, and respirators when the work environment necessitates them, as indicated by the presence of dust and potential debris. By stopping the work and instructing the plumber to don the required PPE, the inspector is directly addressing a violation and mitigating a foreseeable risk, thereby fulfilling their duty to ensure a safe working environment. Incorrect approaches analysis. An approach that involves overlooking the situation because the work is nearly complete is professionally unacceptable. This failure to enforce safety regulations, regardless of the project stage, directly violates the inspector's mandate. It creates a precedent for lax enforcement and exposes workers to unnecessary risks, even for short durations. Ethically, it compromises the inspector's integrity and commitment to worker safety. An approach that involves documenting the violation but allowing the work to continue without immediate correction is also professionally flawed. While documentation is important, it does not address the immediate hazard. The regulations are designed to prevent harm during the work, not just to record its occurrence. Allowing the work to proceed without the required PPE means the risk of injury remains present, which is a failure in proactive safety enforcement. An approach that involves issuing a warning to the site supervisor without directly addressing the plumber performing the work is insufficient. While communication with supervisors is part of the process, the immediate responsibility for ensuring the individual worker's compliance lies with the inspector on the ground. The violation is occurring at the individual level, and the most effective and immediate corrective action is to address it directly with the person performing the task. This approach risks the violation continuing if the supervisor does not effectively relay or enforce the warning. Professional reasoning. Professionals in this role should employ a decision-making process that prioritizes immediate safety and regulatory compliance. This involves 1. Identifying the specific regulation being violated, e.g., requirements for eye protection, gloves, respirators. 2. Assessing the immediate risk posed by the violation. 3. Taking direct corrective action to eliminate the hazard, e.g., stopping work and instructing the worker to use PPE. 4. Documenting the violation and the corrective action taken. 5. Following up to ensure sustained compliance. This systematic approach ensures that safety is paramount and that regulations are consistently and effectively enforced. Question 3. Comparative studies suggest that plumbing inspectors often face situations where contractors propose alternative methods or materials that deviate from the explicit requirements of the International Plumbing Code, IPC, as adopted by the local jurisdiction. In a scenario where a contractor proposes using a specific type of pipe jointing compound that is not explicitly listed in the IPC's approved materials, but claims it offers equivalent or superior performance and longevity. What is the most appropriate course of action for a commercial plumbing inspector to take to ensure compliance with the IPC and protect public health and safety? Option A. Require the contractor to provide documented proof from the manufacturer or a recognized testing laboratory demonstrating that the proposed jointing compound meets or exceeds the performance and safety standards equivalent to those specified by the IPC for approved materials, and consult with the authority having jurisdiction if necessary for approval of the alternative. Option B. Rely on personal experience and past practices with similar materials to determine if the proposed jointing compound is acceptable without requiring further documentation. Option C. Accept the contractor's assurance of equivalent or superior performance and allow the use of the proposed jointing compound to avoid delaying the project. Option D. Inform the contractor that only materials explicitly listed in the IPC are permissible and reject the proposed alternative outright, regardless of any claims of equivalence. The correct answer is A. Require the contractor to provide documented proof from the manufacturer or a recognized testing laboratory demonstrating that the proposed jointing compound meets or exceeds the performance and safety standards equivalent to those specified by the IPC for approved materials, and consult with the authority having jurisdiction if necessary for approval of the alternative. Explanation. This scenario is professionally challenging because it requires the inspector to balance the immediate need for a functional plumbing system with the long-term implications of code compliance and public safety. The inspector must make a judgment call based on their understanding of the applicable plumbing codes and regulations, recognizing that a deviation, even if seemingly minor, could have significant consequences. The challenge lies in interpreting the intent of the code and applying it to a specific, real-world situation where strict adherence might be impractical or lead to undue hardship, while simultaneously ensuring no compromise to safety or health. The correct approach involves a thorough understanding and application of the International Plumbing Code, IPC, as adopted by the relevant jurisdiction. This approach prioritizes safety and public health by ensuring all plumbing work meets or exceeds the minimum standards set forth in the code. When a deviation is proposed, the inspector must verify that any alternative method or material provides an equivalent level of sanitation, health, and safety as that prescribed by the code. This often involves consulting code interpretations, manufacturer's data, and potentially seeking approval from the authority having jurisdiction for any proposed variances. The ethical and regulatory justification stems directly from the inspector's duty to enforce the code for the protection of the public. An incorrect approach that relies solely on the contractor's assurance without independent verification fails to uphold the inspector's responsibility. This approach bypasses the critical review process mandated by the code and could inadvertently permit unsafe or non-compliant installations. The regulatory failure is in not performing due diligence, and the ethical failure is in abdicating the inspector's oversight role. Another incorrect approach that prioritizes expediency over code compliance is equally problematic. While efficiency is desirable, it cannot come at the expense of safety or regulatory adherence. This approach risks overlooking potential hazards or future problems that a thorough inspection would identify. The regulatory failure is in compromising the integrity of the inspection process, and the ethical failure is in prioritizing speed over the public good. Third incorrect approach that involves making a decision based on past practices without consulting the current code is also unacceptable. Plumbing codes are updated to reflect advancements in technology, materials, and safety standards. Relying on outdated knowledge or informal grandfathering can lead to the acceptance of installations that are no longer considered safe or compliant. The regulatory failure is in not adhering to the current, legally adopted code, and the ethical failure is in potentially exposing the public to risks associated with outdated practices. Professionals should employ a decision-making framework that begins with a clear understanding of the applicable code requirements. When faced with a deviation or a question of interpretation, the inspector should 1. Identify the specific code section relevant to the situation. 2. Assess whether the proposed method or material meets the intent and performance requirements of the code. 3. If an alternative is proposed, require documentation demonstrating equivalent safety and sanitation. 4. Consult with the AHJ if there is any ambiguity or if a formal variance is being requested. 5. Document all decisions and justifications thoroughly. This systematic approach ensures that decisions are grounded in regulatory requirements and ethical responsibilities. Question 4. Cost-benefit analysis shows that installing a commercial tankless water heater with a modified venting system, which deviates from the manufacturer's specifications and local code requirements for exhaust termination, will save the building owner $5,000 in installation costs. The contractor assures the inspector that the modified venting is sufficient and will not pose a safety risk. As the commercial plumbing inspector, what is your absolute priority in this situation? Option A. Ensure the water heater installation strictly adheres to all manufacturer specifications and applicable plumbing codes, including proper venting and safety device installation, regardless of the cost savings. Option B. Accept the contractor's assurance that the modified venting is sufficient and approve the installation, prioritizing the client's immediate financial benefit. Option C. Approve the installation with a note for the contractor to address the venting issue within 30 days, acknowledging the cost savings for the owner. Option D. Recommend a less expensive but code-compliant water heater model to the owner to mitigate the cost concerns while still ensuring safety. The correct answer is A. Ensure the water heater installation strictly adheres to all manufacturer specifications and applicable plumbing codes, including proper venting and safety device installation, regardless of the cost savings. Explanation. This scenario presents a professional challenge for a commercial plumbing inspector due to a conflict between perceived cost savings for a client and the non-negotiable requirements of public safety and code compliance. The inspector must prioritize adherence to the established regulatory framework over client expediency or financial considerations. The correct approach involves strictly adhering to the applicable plumbing codes, specifically those governing the installation of water heaters, including venting and safety devices. This is mandated by the inspector's professional responsibility to ensure public health and safety. As outlined in the Commercial Plumbing Inspector Certification, Exams Governing Regulations, the code dictates specific requirements for venting to prevent the buildup of hazardous combustion byproducts and the installation of safety devices like temperature and pressure relief (TPR) valves to prevent catastrophic failure. Ignoring these requirements, even if presented as a cost-saving measure, directly violates the inspector's duty and the intent of the regulations. An incorrect approach would be to approve the installation based on the contractor's assurance of cost savings and a vague promise of future compliance. This fails to uphold the inspector's duty to verify immediate code compliance and places the public at risk. Another incorrect approach is to allow the installation with a note for future correction, as this bypasses the fundamental requirement for compliant installation from the outset and creates a liability for both the inspector and the building occupants. Finally, accepting the contractor's argument that the existing venting is adequate without verifying it against current code requirements is a failure to perform due diligence and a direct contravention of the inspector's role. Professionals should employ a decision-making framework that prioritizes code compliance and public safety above all else. This involves a thorough understanding of the applicable codes, a commitment to objective inspection, and the courage to enforce regulations, even when faced with pressure or perceived economic benefits for the client. When a discrepancy is identified, the professional response is to clearly communicate the code violation and require correction before approving the installation, rather than seeking workarounds or compromises that jeopardize safety. Question 5. Investigation of a commercial building's waste piping system reveals that all connections appear to be securely joined and properly sealed. However, the inspector suspects potential issues with the system's capacity. Which approach best ensures compliance with waste piping requirements regarding fixture units and drainage calculations without performing complex on-site calculations? Option A. Compare the number of installed fixtures and their corresponding fixture unit values against the code-specified minimum pipe sizes for the waste branches and main stacks serving them. Option B. Inspect a representative sample of pipe connections to ensure proper joining techniques are employed. Option C. Attempt to estimate the total fixture unit load by observing the types of fixtures present, and then mentally calculate the required pipe diameters. Option D. Visually confirm that all pipe joints are watertight and that the pipes are adequately supported. The correct answer is A. Compare the number of installed fixtures and their corresponding fixture unit values against the code-specified minimum pipe sizes for the waste branches and main stacks serving them. Explanation: this scenario presents a professional challenge for a commercial plumbing inspector because it requires the inspector to move beyond simple visual confirmation of pipe connections and delve into the underlying principles of drainage system design. The challenge lies in ensuring that the system, while appearing correctly assembled, is functionally sound and compliant with the established fixture unit load and pipe sizing requirements, which are critical for preventing backups and ensuring public health. Careful judgment is required to assess the adequacy of the waste piping without resorting to complex calculations, focusing instead on the inspector's understanding of the principles and their application. The correct approach involves a comparative analysis of the installed waste piping against the established fixture unit load and the corresponding minimum pipe sizes as dictated by the relevant plumbing code. This approach is correct because it directly addresses the core requirements of waste piping design, accommodating the expected flow and ensuring adequate velocity for self-cleansing. By referencing the code's tables and guidelines for fixture units and pipe sizing, the inspector can verify that the installed system is designed to handle the anticipated load, thereby preventing potential failures like blockages and backups. This aligns with the ethical and regulatory responsibility to ensure public safety and health through compliant plumbing installations. An incorrect approach that relies solely on the visual appearance of the pipe connections, assuming that if they are properly joined, the system will function, is professionally unacceptable. This fails to consider the critical aspect of pipe sizing relative to the fixture unit load. A visually perfect connection on an undersized pipe will inevitably lead to operational problems. Another incorrect approach, which involves attempting to perform detailed drainage calculations on site without the necessary tools or time, is also professionally flawed. While calculations are the basis of code requirements, the inspector's role is to verify compliance with the code's established parameters, not to re-engineer the system in the field. This approach is inefficient and can lead to errors. Finally, an approach that prioritizes speed over thoroughness, by only checking a sample of connections without considering the overall fixture unit load, is a significant regulatory failure. This overlooks the cumulative effect of multiple fixtures and can result in a system that is overloaded and prone to failure, compromising the integrity of the installation and the safety of the occupants. The professional reasoning process for similar situations should involve: 1. Understanding the fundamental principles of waste piping design as outlined in the applicable plumbing code, particularly concerning fixture units and pipe sizing. 2. Prioritizing verification of compliance with code-mandated parameters over superficial observations. 3. Utilizing code tables and guidelines to assess the adequacy of the installed system based on its intended use and fixture count. 4. Recognizing the limitations of on-site inspections and focusing on verifying adherence to established design criteria rather than performing complex engineering calculations. Question 6. Process analysis reveals a newly constructed commercial building with an extensive roof area and multiple ground-level loading docks. The storm drainage system includes numerous roof drains, internal downspouts, and a connection to the municipal storm sewer. During the inspection, the inspector observes that the roof drains appear to be correctly positioned and the downspouts are visible. However, the inspector has not yet verified the capacity of the storm sewer connection or assessed the overall drainage gradient of the roof surface to ensure positive drainage away from penetrations. Which approach best represents a comprehensive risk assessment for this storm drainage system? Option A. Visually confirm the placement and apparent condition of roof drains and downspouts, assuming the system will function adequately as long as the visible components are installed. Option B. Prioritize the inspection of the storm sewer connection's cost-effectiveness and ease of installation, as these factors often indicate the designer's intent for a budget-conscious solution. Option C. Conduct a thorough risk assessment by verifying the capacity of the storm sewer connection, confirming the roof's drainage gradient, and evaluating the integration of all components to ensure effective stormwater management under anticipated rainfall conditions. Option D. Rely solely on the manufacturer's specifications for the roof drains and downspouts, assuming that if the components meet these standards, the overall system performance is guaranteed. The correct answer is C. Conduct a thorough risk assessment by verifying the capacity of the storm sewer connection, confirming the roof's drainage gradient, and evaluating the integration of all components to ensure effective stormwater management under anticipated rainfall conditions. Explanation: this scenario presents a professional challenge for a commercial plumbing inspector because it requires a nuanced understanding of storm drainage system design and installation beyond simple code compliance. The inspector must assess the system's ability to effectively manage stormwater runoff under various conditions, considering potential long-term impacts on the building and surrounding environment. This involves a risk assessment approach to identify potential failure points and ensure the system's resilience and longevity, which is crucial for public safety and property protection. Correct approach involves a comprehensive risk assessment of the storm drainage system, focusing on the integration and functionality of roof drains, area drains, and storm sewer connections. This approach is right because it aligns with the overarching goal of plumbing inspection, which is to ensure public health, safety, and welfare. Specifically, it addresses the potential for system failure due to improper sizing, material defects, installation errors, or inadequate maintenance, all of which can lead to localized flooding, structural damage, and environmental contamination. By proactively identifying and mitigating these risks, the inspector upholds professional standards and regulatory intent, ensuring the system performs as designed and prevents future issues. This aligns with the principles of due diligence and professional responsibility inherent in the Commercial Plumbing Inspector Certification exam scope. An incorrect approach that focuses solely on visual confirmation of drain placement without assessing their connectivity and capacity is professionally unacceptable. This failure stems from a lack of thoroughness and an incomplete understanding of the system's hydraulic function. It neglects the critical aspect of how water will actually be conveyed away from the building, potentially leading to undetected design flaws or installation errors that could manifest as significant problems later. This approach violates the ethical obligation to ensure the system's operational integrity and can lead to code violations that are not identified during the inspection. Another incorrect approach that prioritizes cost-effectiveness over system performance is also professionally unsound. While budget considerations are important in construction, they should never compromise the fundamental safety and functionality of a storm drainage system. An inspector's duty is to ensure compliance with established standards that are designed to guarantee performance and prevent hazards. Prioritizing cost savings could lead to the selection of undersized components, inferior materials, or inadequate installation methods, all of which increase the risk of system failure and subsequent damage. This approach disregards the inspector's primary responsibility to public safety and can result in significant financial and environmental liabilities for the building owner and potentially the public. A third incorrect approach that relies solely on manufacturer specifications without verifying field installation and site-specific conditions is also flawed. Manufacturer specifications provide a baseline, but actual site conditions, such as soil type, topography, and anticipated rainfall intensity, can significantly impact the performance of a storm drainage system. An inspector must verify that the installed system is appropriate for the specific site and has been installed correctly according to those specifications and relevant codes. Failure to do so means the inspector is not truly assessing the system's effectiveness in its intended environment, potentially overlooking critical installation errors or design oversights that could lead to system failure. A professional decision-making process for similar situations should involve a systematic evaluation of the storm drainage system's design, installation, and potential performance under various conditions. This includes reviewing design documents, conducting thorough on-site inspections, and considering the specific environmental context. Inspectors should adopt a risk-based approach, prioritizing areas with the highest potential for failure or impact. They must be knowledgeable about relevant codes and standards, but also possess the critical thinking skills to assess how these apply in real-world scenarios. When uncertainties arise, consulting with design professionals or seeking clarification from regulatory authorities is a sign of professional integrity and a commitment to ensuring the highest level of safety and functionality. Question 7. Governance review demonstrates that a newly constructed commercial building has incorporated several water conservation strategies, including low-flow fixtures in restrooms, water-efficient dishwashers in the cafeteria, and a gray water system for landscape irrigation. As the commercial plumbing inspector, what is the most critical aspect to verify regarding these systems to ensure compliance with the governing regulatory framework? Option A. Verifying that the water-efficient appliances have received a general green certification from a widely recognized environmental organization, regardless of specific plumbing code compliance. Option B. Confirming that all low-flow fixtures, water-efficient appliances, and the gray water system are installed and functioning according to the approved plans and meet the specific performance standards and safety requirements outlined in the applicable plumbing codes and standards for water conservation and gray water reuse. Option C. Ensuring that the gray water system's irrigation output is aesthetically pleasing and effectively waters the landscaping without causing water runoff onto adjacent properties. Option D. Approving the gray water system based on the contractor's verbal assurance that it is safe and effective, without requiring any documented proof of performance or compliance with specific code provisions. The correct answer is B. Confirming that all low-flow fixtures, water-efficient appliances, and the gray water system are installed and functioning according to the approved plans and meet the specific performance standards and safety requirements outlined in the applicable plumbing codes and standards for water conservation and gray water reuse. Explanation. This scenario presents a professional challenge due to the need to balance regulatory compliance, public health, and the practical implementation of water conservation measures in a commercial setting. A plumbing inspector must possess a thorough understanding of the applicable codes and standards to ensure that proposed or existing systems meet the minimum requirements for water efficiency, while also safeguarding against potential health risks associated with alternative water sources. The inspector's judgment is critical in evaluating the suitability and safety of these systems within the specific context of the building and its intended use. The correct approach involves a comprehensive review of the building plans and on-site inspections to verify that all installed or proposed low-flow fixtures, water-efficient appliances, and gray water systems comply with the specific provisions of the Commercial Plumbing Inspector Certification exam's governing regulatory framework. This includes confirming that fixtures meet the mandated flow rates, appliances are certified for water efficiency, and gray water systems are designed, installed, and maintained according to approved standards, ensuring proper filtration, treatment, and segregation from potable water supplies to prevent cross-contamination and protect public health. Adherence to these specific code requirements is paramount for ensuring safety and compliance. An incorrect approach would be to approve a gray water system that has not undergone proper testing or certification for its treatment efficacy, potentially allowing untreated or inadequately treated water to be used for non-potable purposes, thereby posing a significant public health risk. Another incorrect approach would be to overlook the flow rate requirements for new low-flow fixtures, thereby failing to enforce the water conservation mandates of the regulations. Furthermore, accepting water-efficient appliance certifications that are not recognized or approved by the governing body would also be a failure to comply with the established standards. Professional decision-making in such situations requires a systematic process. First, thoroughly understanding the specific requirements of the applicable plumbing codes and standards related to water conservation and gray water systems. Second, meticulously reviewing all submitted documentation, including plans, specifications, and product certifications, against these requirements. Third, conducting thorough on-site inspections to confirm that the installation matches the approved plans and that all components function as intended and meet safety standards. Finally, documenting all findings clearly and communicating any deficiencies or required corrections in a professional and actionable manner, always prioritizing public health and safety alongside regulatory compliance. Question 8. The review process indicates that a commercial building's plumbing system, installed approximately 35 years ago, is currently operational with no visible leaks. However, upon closer inspection, the inspector observes significant external corrosion on a section of galvanized steel piping in a damp basement area. The inspector must determine the appropriate course of action based on the governing plumbing code. Option A. Prove the existing piping as compliant because it is currently functional and not actively leaking. Option B. Recommend the building owner consider proactive replacement of all galvanized steel piping in the building as a preventative measure. Option C. Document the observed external corrosion and require further investigation or remediation if the corrosion is deemed to compromise the pipe's integrity or serviceability according to code. Option D. Issue a notice of violation for the galvanized steel piping solely based on its age, mandating its immediate replacement. The correct answer is C. Document the observed external corrosion and require further investigation or remediation if the corrosion is deemed to compromise the pipe's integrity or serviceability according to code. Explanation: this scenario is professionally challenging because it requires the inspector to balance the immediate need for a building to be functional with the long-term safety and compliance of its plumbing system. The inspector must make a judgment call based on the observed condition of the materials and the potential risks associated with their continued use, all while adhering strictly to the applicable plumbing code. The challenge lies in interpreting the code's intent regarding material suitability and serviceability, especially when dealing with materials that may be nearing the end of their expected lifespan or showing signs of degradation. The correct approach involves a thorough inspection of the existing plumbing materials, specifically focusing on signs of corrosion, leaks, or other damage that could compromise the system's integrity. This approach is right because it directly addresses the core responsibility of a plumbing inspector, ensuring public health and safety by verifying that plumbing systems are installed and maintained in accordance with the governing code. The International Plumbing Code, IPC, or Uniform Plumbing Code, UPC, depending on the jurisdiction's adoption, would be the primary regulatory framework. These codes typically specify acceptable materials and require that plumbing systems be maintained in a watertight condition, free from defects that could lead to leaks or contamination. Identifying and documenting any material degradation that violates these principles is paramount. An incorrect approach would be to assume that because the system is currently functional and not actively leaking, it meets code requirements. This fails to acknowledge the proactive nature of code enforcement, which aims to prevent future failures. Another incorrect approach is to rely solely on the age of the material without assessing its actual condition. While age can be a factor in material degradation, it is not the sole determinant of compliance. The code focuses on the material's current state and its ability to perform its intended function safely. A further incorrect approach would be to recommend immediate replacement of all materials of a certain age without a specific code violation being identified. This goes beyond the inspector's mandate, which is to enforce the code, not to dictate unnecessary upgrades based on arbitrary criteria. Professionals should approach such situations by first understanding the specific code provisions related to plumbing materials and their serviceability. They should then conduct a systematic visual inspection, looking for objective evidence of material failure or degradation. Documentation of findings, including photographic evidence, is crucial. If there is any doubt about the material's compliance or serviceability, the inspector should consult the relevant code sections and, if necessary, seek clarification from their supervisor or a qualified professional engineer. The decision-making process should always prioritize public safety and adherence to the established regulatory framework. Question 9. The performance metrics show that a newly installed graywater recycling system in a commercial building is reportedly functioning and has been in operation for a short period without any visible leaks or immediate operational issues. However, during the inspection, it appears that certain components, specifically the trap and vent configuration for the kitchen sink discharge into the graywater system, do not precisely align with the typical configurations illustrated in the International Plumbing Code (IPC) for standard drainage systems. The installer asserts that the system is designed to be efficient and that the current setup achieves the intended purpose of diverting graywater. As a commercial plumbing inspector certified under the International Plumbing Code, what is the most appropriate course of action? Option A. Reject the graywater system and require the installer to reconfigure the trap and vent system to precisely match the illustrations for standard drainage systems in the IPC, regardless of the system's current functionality. Option B. Advise the installer to consult with a plumbing engineer to redesign the trap and vent system, as the current configuration deviates from standard IPC illustrations, and defer final inspection until a professional engineer's stamp is provided. Option C. Conduct a detailed review of the specific IPC provisions related to graywater systems and their integration with standard drainage, verifying compliance with all applicable requirements, and document any deviations from the code's intent or specific provisions for further action. Option D. Approve the graywater system as installed, given that it is operational and the installer claims it achieves its intended purpose, and the deviations from standard trap and vent illustrations are minor. The correct answer is D. Approve the graywater system as installed, given that it is operational and the installer claims it achieves its intended purpose, and the deviations from standard trap and vent illustrations are minor. Explanation: this scenario presents a professional challenge for a commercial plumbing inspector due to the potential for conflicting interpretations of code requirements when dealing with a newly installed system that appears to meet some but not all provisions of the International Plumbing Code, IPC. The inspector must exercise careful judgment to ensure public health and safety are not compromised, while also adhering strictly to the applicable code. The challenge lies in balancing the intent of the code with the practical application in a real-world installation, especially when updates or specific interpretations might be in question. The correct approach involves a thorough review of the International Plumbing Code, IPC, as adopted by the relevant jurisdiction, specifically focusing on the sections pertaining to the installation of the new greywater system. This includes verifying compliance with all applicable provisions, such as those related to material standards, pipe sizing, trap requirements, venting, and discharge points, as outlined in the IPC. The inspector must then document any deviations from the code and clearly communicate these to the responsible parties, referencing the specific IPC sections that are not met. This approach is correct because it directly upholds the inspector's duty to enforce the adopted code, ensuring that all installations meet the minimum standards for safety and sanitation established by the IPC. Adherence to the IPC is paramount for public health and prevents potential hazards associated with improper plumbing. An incorrect approach would be to approve the system solely because it appears to be functional and has been in use without immediate apparent issues. This fails to acknowledge that the IPC's requirements are preventative and address potential future failures or health risks that may not be immediately visible. It also bypasses the inspector's responsibility to verify full code compliance, potentially leading to long-term problems. Another incorrect approach would be to rely on anecdotal evidence or the installer's assurance that the system works without independent verification against the IPC. This demonstrates a lack of due diligence and an abdication of the inspector's professional responsibility to apply the code objectively. It prioritizes convenience over safety and compliance. A third incorrect approach would be to make a judgment based on personal experience or assumptions about how similar systems are typically installed in other jurisdictions, without referencing the specific IPC provisions applicable to this commercial installation. This violates the strict jurisdiction compliance requirement and introduces variability and potential noncompliance with the adopted code. The professional decision-making process for similar situations should involve 1. Identifying the specific code sections relevant to the installation in question. 2. Conducting a systematic inspection to verify compliance with each relevant code provision. 3. Documenting all findings, both compliant and non-compliant, with specific code references. 4. Communicating findings clearly and professionally to the responsible parties, outlining required corrective actions. 5. Following up to ensure all deficiencies are rectified before final approval. This systematic and code-centric approach ensures thoroughness, fairness, and adherence to the inspector's mandate. Question 10. Assessment of a plumbing permit application for a commercial building reveals a note from the contractor indicating a proposed modification to the standard backflow prevention device installation due to site constraints. The inspector's primary responsibility is to ensure compliance with the adopted plumbing code, which mandates specific requirements for backflow prevention to protect the potable water supply. Which of the following actions best reflects the inspector's role in this situation, prioritizing risk assessment and code compliance? Option A. Deny the permit application outright, citing the deviation from standard installation without further inquiry. Option B. Approve the permit immediately, trusting the contractor's expertise and note regarding site constraints. Option C. Request revised plans or additional documentation from the contractor that clearly demonstrates how the proposed installation will meet all applicable code requirements for backflow prevention, and schedule a pre-installation meeting if necessary. Option D. Approve the permit with a general condition that the backflow prevention device must be installed in accordance with the code, leaving the interpretation of compliance to the contractor. The correct answer is B. Approve the permit immediately, trusting the contractor's expertise and note regarding site constraints. Explanation: this scenario presents a professional challenge because it requires the inspector to balance the need for efficient project progression with the absolute necessity of ensuring public safety and adherence to established plumbing codes. The inspector must make a judgment call based on the information available, understanding that a premature approval could lead to hazardous conditions, while an unwarranted delay could cause significant financial and logistical problems for the contractor and building owner. The core of the challenge lies in interpreting the intent and application of the code in a real-world, potentially ambiguous situation. The correct approach involves a thorough review of the submitted plans against the applicable plumbing code, specifically focusing on the sections pertaining to backflow prevention devices and their installation requirements. This approach is correct because it directly addresses the potential risk identified by the contractor's note. The inspector must verify that the proposed installation meets the code's intent for preventing contamination of the potable water supply. This aligns with the inspector's ethical and regulatory duty to uphold public health and safety by ensuring all plumbing systems are installed in accordance with the adopted codes. The inspector's role is to enforce these codes, and a proactive review of potential issues before final approval is a fundamental aspect of this responsibility. An incorrect approach would be to approve the permit based solely on the contractor's assurance without independent verification. This fails to uphold the inspector's duty to enforce the code and assess compliance. It relies on a third party's interpretation rather than the inspector's own professional judgment and code knowledge, creating a significant risk of code violations going undetected. Another incorrect approach would be to deny the permit outright without further investigation or communication. A caution is necessary. An outright denial without understanding the contractor's proposed solution or offering guidance on code compliance can be seen as an overreach and an impediment to legitimate construction, especially if the contractor's note indicates a good faith effort to address a potential issue. This approach lacks the collaborative and investigative spirit expected of an inspector. A third incorrect approach would be to approve the permit with a vague condition that the backflow prevention be installed correctly. This is insufficient because it lacks specificity and does not provide clear guidance to the contractor or a measurable standard for inspection. It shifts the burden of defining correctly back to the contractor without the inspector having confirmed the proposed method meets code requirements. The professional decision-making process for similar situations involves a systematic approach. 1. Identify the potential risk or ambiguity presented, e.g., the contractor's note about backflow prevention. 2. Consult the relevant sections of the adopted plumbing code to understand the specific requirements and intent. 3. Review the submitted plans and any accompanying documentation for compliance with these requirements. 4. If ambiguity or potential noncompliance exists, communicate with the applicant contractor to seek clarification or request revised plans that demonstrate code compliance. 5. Make a decision based on a thorough understanding of the code and the presented information, prioritizing public safety and code adherence. 6. Document all communications and decisions clearly. Question 11. Upon reviewing the installation of a new commercial water softener and filtration system in a restaurant, what is the most comprehensive approach for a plumbing inspector to ensure compliance with water quality and public health standards? Option A. Accept the installation based on the contractor's assurance that the system will improve water quality and meet all necessary health department requirements. Option B. Verify that the system is installed according to manufacturer's instructions and that all visible connections are secure and leak-free. Option C. Confirm that the system's installation adheres to all relevant sections of the adopted plumbing code, that appropriate backflow prevention is in place, that regeneration discharge is properly routed, and that the owner has a documented maintenance schedule for the system. Option D. Focus solely on the physical layout and pipe sizing of the system, as water quality is primarily the responsibility of the water treatment equipment manufacturer. The correct answer is B. Verify that the system is installed according to manufacturer's instructions and that all visible connections are secure and leak-free. Explanation. This scenario presents a professional challenge because a commercial plumbing inspector must balance the immediate need for potable water with the long-term implications of water treatment system installation and maintenance. The inspector's role extends beyond simply verifying code compliance at the point of installation. It involves ensuring the system contributes to overall water quality and public health, as dictated by the relevant plumbing codes and health regulations. Careful judgment is required to assess not only the physical installation, but also the intended operational effectiveness and adherence to water quality standards. The correct approach involves a thorough review of the water softener and filtration system's installation against the applicable plumbing codes, specifically focusing on requirements for backflow prevention, material compatibility, and proper drainage for regeneration cycles. Furthermore, it necessitates verifying that the system's design and intended operation align with local health department guidelines for potable water treatment, and that the owner has a documented maintenance plan. This approach is correct because it directly addresses the inspector's mandate to ensure safe and sanitary plumbing systems, encompassing both installation integrity and functional water quality, as defined by regulatory frameworks. Adherence to codes like the International Plumbing Code, IPC, or Uniform Plumbing Code, UPC, depending on the jurisdiction and relevant state or local health department regulations, is paramount. An incorrect approach that focuses solely on the physical installation, without considering the system's impact on water quality, fails to meet the comprehensive requirements of plumbing inspection. This oversight could lead to the installation of a system that, while physically compliant, compromises the potability of the water or creates a health hazard due to improper regeneration discharge or inadequate filtration. Another incorrect approach, which relies solely on the manufacturer's claims without independent verification against code and health standards, is also professionally deficient. Manufacturer's specifications do not supersede regulatory requirements, and an inspector must ensure compliance with the law, not just product marketing. Lastly, neglecting to confirm a maintenance plan for the system is a critical failure, as water treatment systems require regular upkeep to remain effective and prevent the proliferation of contaminants, a direct concern for public health and a responsibility implicitly covered by ensuring a safe and sanitary plumbing system. Professional decision-making in such situations requires a systematic approach. First, identify all applicable codes and regulations, e.g., IPC, UPC local health codes. Second, conduct a comprehensive inspection that covers both the physical installation and the system's intended function regarding water quality. Third, verify that the owner or responsible party has a clear understanding of and commitment to the system's ongoing maintenance requirements. Finally, document all findings thoroughly, citing specific code provisions where applicable, to ensure accountability and protect public health. Question 12. System analysis indicates a plumbing contractor is using a portable electric pipe threader on a commercial project. During your inspection, you observe that the power cord for the threader has a visibly frayed section near the plug, and the operator appears to be struggling to maintain control of the tool, suggesting a lack of familiarity with its operation. The pipe threads themselves, however, appear to be adequately formed. What is the most appropriate course of action for the commercial plumbing inspector? Option A. Advise the operator to be more careful with the frayed cord and continue the inspection, as the primary focus is on the quality of the pipe threads. Option B. Document the frayed cord and the operator's technique as a minor observation and allow the work to continue, assuming it will be corrected during a final inspection. Option C. Immediately halt the use of the power threader due to the frayed power cord and the operator's apparent lack of proficiency, and require the contractor to provide a properly maintained tool and demonstrate competent operation before work can resume. Option D. Approve the work as the pipe threads appear functional, assuming the contractor will address any minor issues with the tool later. The correct answer is C. Immediately halt the use of the power threader due to the frayed power cord and the operator's apparent lack of proficiency, and require the contractor to provide a properly maintained tool and demonstrate competent operation before work can resume. Explanation. This scenario presents a professional challenge for a commercial plumbing inspector because it requires the inspector to balance the need for efficient project completion with the absolute imperative of ensuring safety and compliance with established standards. The use of power tools introduces inherent risks, and the inspector's role is to verify that these risks are mitigated through proper operation, maintenance, and adherence to safety protocols. The challenge lies in distinguishing between minor deviations that do not compromise safety or code compliance, and those that represent significant hazards or violations. Careful judgment is required to avoid unnecessary delays while upholding the integrity of the inspection process. The correct approach involves a thorough visual inspection of the power threader's condition, including the power cord, housing, and cutting dies, and observing the operator's technique to ensure it aligns with safe operating procedures and manufacturer guidelines. This approach is correct because it directly addresses the potential hazards associated with power tool operation. Specifically, it aligns with general safety principles and the implied requirements of commercial building codes that mandate safe working conditions and the use of equipment in good repair. While specific code sections might not detail every aspect of power tool operation, the inspector's duty is to ensure that the tools used do not create an unsafe environment or compromise the quality of the plumbing installation. Verifying the operator's familiarity with the tool and their adherence to safety practices is crucial for preventing accidents and ensuring the long-term integrity of the plumbing system. An incorrect approach that involves overlooking the frayed power cord and the operator's apparent lack of familiarity with the tool is professionally unacceptable. This failure constitutes a direct violation of safety regulations and ethical responsibilities. A frayed power cord is a significant electrical hazard, posing a risk of shock or fire, and directly contravenes general workplace safety standards that require equipment to be in good working order. Ignoring this visible defect demonstrates a lack of due diligence and a disregard for the safety of workers and the integrity of the building. Furthermore, allowing an unqualified operator to use a power tool creates a high risk of improper operation, leading to damaged materials, faulty installations, and potential accidents. This approach fails to uphold the inspector's duty to ensure compliance with safety standards and the proper application of plumbing materials. Another incorrect approach, which is to approve the work solely because the pipe threads appear functional, is also professionally flawed. While the end result of the threading might seem acceptable, this approach ignores the process and the inherent risks involved. The inspector's responsibility extends beyond the superficial appearance of the finished product to the safety and compliance of the methods used to achieve it. Proving work performed with unsafe equipment or by untrained personnel sets a dangerous precedent and undermines the entire purpose of the inspection. This approach fails to address potential future failures that could arise from improper threading techniques or tool malfunctions that were not detected due to the lack of process inspection. The professional decision-making process for similar situations should involve a systematic evaluation of both the equipment and the operator. The inspector must first assess the condition of the power tool for any visible defects that could compromise safety or performance. This includes checking power cords, guards, and operational components. Simultaneously, the inspector should observe the operator's technique and assess their apparent understanding of the tool's operation and safety features. If any safety concerns are identified, the inspector must address them directly with the contractor, citing relevant safety regulations or code requirements. The inspector should not proceed with approving work until all safety hazards are rectified and the operator demonstrates competence. This methodical approach ensures that safety and compliance are prioritized throughout the inspection process. Question 13. Performance analysis shows that a large-scale commercial water heating system, consisting of multiple high-capacity boilers and interconnected storage tanks, is operating with intermittent fluctuations in output temperature and pressure reading that fall slightly outside the manufacturer's recommended operating range, though still within acceptable safety limits for immediate use. The system is currently providing hot water to the building. What is the most appropriate course of action for a certified commercial plumbing inspector? Option A. Advise the building owner that since hot water is being produced, no further action is required at this time, and the system can continue operating as is. Option B. Issue a notice of violation for exceeding the manufacturer's recommended operating parameters, requiring immediate adjustment of the system. Option C. Recommend immediate replacement of the boilers and storage tanks due to the observed performance deviations, citing potential future failures. Option D. Document the observed fluctuations and recommend a detailed diagnostic inspection by a qualified service technician to identify the root cause, referencing specific code sections related to performance monitoring and system integrity. The correct answer is D. Document the observed fluctuations and recommend a detailed diagnostic inspection by a qualified service technician to identify the root cause, referencing specific code sections related to performance monitoring and system integrity. Explanation. This scenario presents a professional challenge because it requires the inspector to interpret complex system performance data in the context of regulatory compliance for large-scale commercial water heating systems. The challenge lies in distinguishing between normal operational fluctuations and potential code violations or safety hazards that could impact public health and safety. Careful judgment is required to ensure the system operates efficiently and safely, meeting all applicable standards without imposing unnecessary burdens on the building owner. The correct approach involves a thorough review of the performance data against the manufacturer's specifications and the relevant sections of the adopted plumbing code, specifically focusing on requirements for commercial water heaters, boilers, and storage tanks. This approach is right because it directly addresses the inspector's mandate to verify compliance with established safety and performance standards. The adopted plumbing code, which would be the basis for the commercial plumbing inspector certification exam, dictates the minimum requirements for the installation, operation, and maintenance of such systems. By cross-referencing the performance data with these codes and manufacturer guidelines, the inspector can accurately identify any deviations that compromise safety, efficiency, or longevity, thereby upholding professional responsibility and ensuring public welfare. An incorrect approach would be to dismiss the performance anomalies solely because the water heater is still producing hot water. This is a regulatory failure because it ignores potential underlying issues that, while not immediately catastrophic, could lead to future failures, energy waste, or safety risks, all of which are addressed by plumbing codes. Another incorrect approach would be to recommend immediate replacement based on minor, explainable fluctuations without a thorough investigation. This is an ethical failure as it could lead to unnecessary financial burdens for the building owner and demonstrates a lack of due diligence in assessing the true condition of the equipment. Finally, focusing only on the visible components of the water heater and disregarding the performance data would be a significant regulatory failure, as modern plumbing codes often require verification of system performance through testing and data analysis, especially for large-scale commercial installations. Professional decision-making in similar situations requires a systematic process. First, understand the scope of the inspection and the applicable codes. Second, gather all relevant data, including performance metrics, manufacturer documentation, and installation records. Third, analyze the data critically, comparing it against code requirements and best practices. Fourth, if anomalies are detected, investigate the root cause thoroughly. Fifth, communicate findings clearly and professionally, providing specific code references to support any required corrective actions. This methodical approach ensures that decisions are based on objective evidence and regulatory mandates, promoting safety and compliance. Question 14. Implementation of a new commercial building's drainage system has utilized both PVC and cast iron piping. As the commercial plumbing inspector, what is the most critical factor to consider when verifying compliance regarding these materials, their sizing, slope, and cleanout requirements? Option A. Ensuring that all drainage piping is installed with the steepest possible slope to maximize flow and minimize the risk of blockages, regardless of material. Option B. Confirming that the chosen material for each section of piping is explicitly permitted by the adopted plumbing code for its specific application, and that all sizing, slope, and cleanout requirements as detailed in the code are met. Option C. Verifying that a sufficient number of cleanouts are installed, assuming that the material and sizing are secondary concerns as long as the system appears to be draining. Option D. Prioritizing the use of cast iron piping throughout the entire drainage system, due to its perceived superior durability and longevity compared to PVC. The correct answer is B. Confirming that the chosen material for each section of piping is explicitly permitted by the adopted plumbing code for its specific application, and that all sizing, slope, and cleanout requirements as detailed in the code are met. Explanation. This scenario presents a common challenge for commercial plumbing inspectors, ensuring compliance with material and installation requirements for drainage piping, specifically comparing PVC and cast iron. The challenge lies in understanding the nuanced application of different materials based on their properties, intended use, and the specific requirements of the governing plumbing code. Inspectors must not only identify the materials, but also verify their correct application, sizing, slope, and the presence and type of cleanouts as mandated by the code. This requires a deep understanding of the code's intent and the practical implications of material choices. The correct approach involves a thorough review of the installed drainage piping, comparing it against the applicable sections of the adopted plumbing code. This includes verifying that the chosen material, PVC or cast iron, is permitted for the specific application, e.g., above ground vs. underground specific fixture types, that the pipe is correctly sized according to drainage fixture unit loads and flow rates, that the required slope is maintained to ensure proper drainage and prevent solids from settling, and that cleanouts are installed at appropriate intervals and configurations for maintenance access. This approach is correct because it directly addresses all mandated requirements of the plumbing code, ensuring the safety, functionality, and longevity of the drainage system. It prioritizes code compliance and the public health implications of a properly functioning drainage system. An incorrect approach would be to assume that all drainage piping is interchangeable or that a single material is universally superior. For instance, solely focusing on the perceived durability of cast iron without considering its installation limitations or cost, or conversely, assuming PVC is always acceptable without verifying its suitability for the specific application and its resistance to potential damage or degradation, represents a failure to adhere to code-specific requirements. Another incorrect approach would be to overlook the critical importance of proper slope and cleanout installation, focusing only on the material type. This failure to address all aspects of drainage piping installation as outlined in the code can lead to system blockages, backups, and potential health hazards, all of which are direct violations of the inspector's professional responsibility and the code's intent. Professional reasoning in such situations requires a systematic, code-centric approach. Inspectors should first identify the specific code adopted for the jurisdiction. Then they must meticulously examine the installed plumbing system, cross-referencing each component and installation detail against the relevant code provisions for drainage piping materials, sizing, slope, and cleanouts. When faced with a choice between materials or installation methods, the inspector must consult the code to determine which is permitted and appropriate for the specific context. If ambiguity exists, consulting code interpretations or seeking clarification from the code official is a professional and ethical step. The ultimate goal is to ensure the installation meets the minimum standards for public health and safety as defined by the governing regulations. Question 15. Which approach would be most effective for a commercial plumbing inspector tasked with verifying the safety and compliance of potable water systems that may utilize municipal water, private wells, or rainwater harvesting, while adhering strictly to the Commercial Plumbing Inspector Certification Exam's regulatory framework? Option A. Implementing a standardized, comprehensive inspection checklist that covers all potential potable water sources equally, regardless of their specific nature. Option B. Relying primarily on the property owner's self-reported maintenance records and assurances for private wells and rainwater harvesting systems, with minimal direct inspection of the source components. Option C. Developing and applying source-specific inspection protocol that address the unique regulatory requirements, potential contaminants, and maintenance needs of municipal systems, private wells, and rainwater harvesting systems. Option D. Focusing exclusively on the visible plumbing infrastructure connected to the building, without conducting a thorough assessment of the wellhead protection, rainwater collection, or storage components. Correct answer is A. Implementing a standardized, comprehensive inspection checklist that covers all potential potable water sources equally, regardless of their specific nature. Explanation. This scenario presents a common challenge for commercial plumbing inspectors, ensuring the integrity and safety of diverse potable water sources beyond standard municipal connections. The challenge lies in the varying regulatory oversight, potential for contamination, and the need for specialized knowledge for each source type. Inspectors must balance compliance with public health mandates, manufacturer specifications, and best practices for each system. The correct approach involves a comprehensive, source-specific inspection protocol. This means understanding the distinct requirements for municipal systems, e.g., cross-connection control, backflow prevention, private wells, e.g., water quality testing, wellhead protection, pump maintenance, and rainwater harvesting systems, e.g., filtration, disinfection, storage integrity, material compatibility. This approach is correct because it directly addresses the specific risks and regulatory frameworks associated with each potable water source, ensuring compliance with relevant plumbing codes and public health standards. For municipal systems, this includes adherence to regulations concerning backflow prevention devices and their testing schedules. For wells, it involves verifying compliance with state and local health department guidelines for well construction and water quality. For rainwater harvesting, it requires ensuring that the system is designed and maintained to prevent contamination, often referencing specific standards for filtration and disinfection to meet potable water quality. An incorrect approach would be to apply a single, generalized inspection checklist to all water sources. This fails to account for the unique risks and regulatory requirements of each system. For instance, a well system has different contamination pathways and testing needs than a municipal supply. Similarly, rainwater harvesting systems introduce concerns about biological and chemical contaminants that are not typically addressed by standard municipal water regulations. This generalized approach risks overlooking critical safety issues specific to wells or rainwater systems, leading to potential public health hazards and noncompliance with applicable codes. Another incorrect approach would be to solely rely on the property owner's assurances regarding the safety and maintenance of non-municipal water sources. While owner cooperation is important, the inspector's professional responsibility is to verify compliance through direct observation, and where necessary, require documentation such as water quality test results or maintenance logs. Delegating the responsibility for ensuring water safety to the owner without independent verification is a dereliction of duty and a failure to uphold public health standards. A third incorrect approach would be to focus only on the visible plumbing components and ignore the source itself. For wells and rainwater harvesting, the source is integral to the potability of the water. Inspection that does not assess the wellhead protection, the integrity of the rainwater collection and storage, or the effectiveness of any treatment systems is incomplete and potentially hazardous. The professional decision-making process for similar situations should involve 1. Identifying the type of potable water source. 2. Recalling or researching the specific regulatory requirements and best practices applicable to that source type within the governing jurisdiction. 3. Developing a tailored inspection checklist that addresses the unique risks and compliance points for that source. 4. Verifying compliance through direct observation, documentation review, and if necessary, recommending specific tests or assessments. 5. Documenting all findings clearly and communicating any deficiencies to the appropriate parties. Question 16. The analysis reveals that a new commercial kitchen is undergoing final plumbing inspections. The contractor has installed a grease interceptor that is smaller than what the plumbing code specifies for an establishment of this size and type, citing cost savings, and a claim that a similar unit has functioned adequately in another, smaller restaurant. The inspector is aware that the code mandates a larger capacity unit to effectively manage the expected grease load and prevent sewer blockages. The contractor is pressuring the inspector to pass the inspection, stating that the delay will impact the restaurant's opening. What is the most appropriate course of action for the plumbing inspector? Option A. Approve the installation of the smaller grease interceptor, assuming the contractor has sufficient experience to make such judgments, and focus on other aspects of the plumbing system for this inspection. Option B. Approve the installation of the smaller grease interceptor, documenting the contractor's assurance that it has worked elsewhere, and noting that a future upgrade can be considered if problems arise. Option C. Reject the installation of the smaller grease interceptor and require the contractor to install a unit that fully complies with the specified size and capacity requirements of the plumbing code before the inspection can be passed. Option D. Allow the restaurant owner to decide whether to accept the smaller grease interceptor, given the contractor's assurances, and document their decision. The correct answer is B. Approve the installation of the smaller grease interceptor, documenting the contractor's assurance that it has worked elsewhere, and noting that a future upgrade can be considered if problems arise. Explanation. The analysis reveals a scenario where a commercial plumbing inspector faces a conflict between a contractor's desire to expedite a project and the strict adherence to plumbing codes designed for public health and safety. This situation is professionally challenging because it requires the inspector to balance project timelines and relationships with the non-negotiable responsibility of enforcing regulations. The inspector must exercise sound judgment, relying on their expertise and the governing code to make an informed decision that prioritizes safety over convenience. The correct approach involves a thorough review of the proposed plumbing system against the applicable commercial plumbing code, specifically focusing on the requirements for grease interceptors in commercial kitchens. This approach is right because it directly addresses the core issue, compliance with established standards. The inspector must verify that the proposed grease interceptor meets the size, capacity, and installation requirements mandated by the code, ensuring it can effectively prevent grease from entering the sanitary sewer system, thereby preventing blockages and environmental contamination. This aligns with the ethical duty of a public servant to uphold regulations for the common good and the professional obligation to ensure public safety and health. An incorrect approach would be to approve the smaller grease interceptor based on the contractor's assurance that it has worked elsewhere. This is a regulatory failure because it bypasses the code's specific requirements for the establishment's size and type of operation. It also represents an ethical failure by prioritizing expediency and a potentially compromised relationship over public health and environmental protection. Another incorrect approach is to allow the installation of the smaller unit with a promise from the contractor to upgrade it later if issues arise. This is a significant regulatory failure, as it permits a non-compliant system to be put into operation, risking immediate or future plumbing failures and potential health code violations. Ethically, it abdicates the inspector's responsibility to ensure compliance from the outset and places the burden of future correction on the public or the establishment, rather than ensuring proper installation from the start. A third incorrect approach is to defer the decision to the restaurant owner without providing clear guidance on code requirements. While client consultation is important, the inspector's role is to interpret and enforce the code. Deferring the decision without asserting the code's mandates is a failure of professional responsibility and a potential regulatory oversight, as the owner may not be aware of or understand the specific plumbing requirements for their establishment. Professionals should approach such situations by first understanding the specific code requirements applicable to the situation. They should then clearly communicate these requirements to the contractor and owner. If a proposed solution deviates from the code, the inspector must explain the specific code sections that are not being met and the reasons behind those requirements, e.g., public health, environmental protection. The inspector should then work with the contractor to find a compliant solution, which may involve modifications to the original plan or the selection of different, code-compliant equipment. Documentation of all communications and decisions is crucial. Question 17. System analysis indicates a commercial facility with a history of cross-connection control violations is undergoing a significant plumbing system upgrade. The facility manager has provided preliminary documentation for new backflow prevention devices, but a comprehensive testing and maintenance schedule for these devices has not yet been finalized. As the commercial plumbing inspector, which of the following actions best ensures compliance with cross-connection control regulations and protects the public water supply? Option A. Issue a conditional approval for the plumbing system, noting the absence of a finalized testing and maintenance schedule, and schedule a follow-up inspection solely for the backflow prevention devices at a later date. Option B. Approve the installation based on the preliminary documentation and advise the facility manager to submit the testing and maintenance schedule once it is finalized, assuming the devices are correctly installed. Option C. Conduct a thorough on-site inspection of the installed backflow prevention devices to verify correct installation and type for the identified hazards, and require the submission of a detailed, approved testing and maintenance schedule before final approval of the plumbing system. Option D. Rely on the facility manager's assurance that a testing and maintenance program will be implemented and focus solely on the visual aspect of the backflow prevention device installation. The correct answer is B. Approve the installation based on the preliminary documentation and advise the facility manager to submit the testing and maintenance schedule once it is finalized, assuming the devices are correctly installed. Explanation. Scenario analysis. This scenario presents a common challenge for commercial plumbing inspectors, ensuring compliance with cross-connection control regulations when faced with a facility that has a history of noncompliance and a new, complex plumbing system. The challenge lies in balancing the need for thorough inspection with the practical realities of facility operations and the potential for subtle, yet critical, deviations from code. The inspector must not only identify potential hazards, but also verify that the installed backflow prevention devices are appropriate for the hazard, correctly installed, and have a robust testing and maintenance program in place, all while adhering strictly to the Commercial Plumbing Inspector Certification exam's specified regulatory framework. Correct approach analysis. The correct approach involves a comprehensive review of the facility's plumbing plans, specifically focusing on the proposed cross-connection control measures. This includes verifying that the selected backflow prevention devices are appropriate for the identified hazard levels as defined by the applicable plumbing code, e.g., International Plumbing Code (IPC) or Uniform Plumbing Code (UPC), depending on the exam's jurisdiction. The inspector must then conduct a thorough on-site inspection to confirm that the devices are installed according to manufacturer specifications and code requirements, paying close attention to isolation valves, test cocks, and proper orientation. Crucially, the inspector must also verify the existence and adequacy of a documented testing and maintenance program, ensuring that certified testers will perform regular testing and that records will be maintained and accessible for future inspections. This approach aligns with the fundamental principle of preventing the contamination of the potable water supply, a core responsibility of plumbing inspectors. Regulatory justification stems from sections of the plumbing code that mandate backflow prevention for specific cross-connections and require regular testing and maintenance of these devices to ensure their continued effectiveness. Incorrect approaches analysis, an approach that relies solely on visual inspection of the installed devices without reviewing plans or verifying the testing and maintenance program, is insufficient. This fails to address the appropriateness of the device for the hazard level and neglects the critical ongoing maintenance required to ensure the device functions correctly over time. Ethically, this is a failure to adequately protect public health. Another incorrect approach would be to assume that because a device is installed, it is automatically compliant and functional. This overlooks the possibility of improper installation, incorrect device selection for the hazard, or a lack of a proper testing schedule, all of which are explicit requirements within plumbing codes. This approach demonstrates a lack of due diligence. Accepting the facility manager's verbal assurance that the devices are tested and maintained without requesting documentation or verifying the testing schedule is also a failure. Plumbing codes typically require documented evidence of testing and maintenance. Relying on verbal assurances bypasses the established regulatory process for ensuring the integrity of the potable water system and can lead to a false sense of security. Professional reasoning. Professionals in this role must adopt a systematic, evidence-based approach. This begins with understanding the regulatory requirements specific to the jurisdiction and the project. The inspector should then engage in a multi-stage process. Plan review to confirm design intent and code compliance, meticulous on-site verification of installation against approved plans and code, and finally, confirmation of the operational and maintenance protocols. When faced with a history of noncompliance, the inspector must exercise heightened vigilance and demand robust evidence of current compliance. This involves not just identifying potential hazards, but actively verifying the implemented safeguards and their ongoing efficacy through documented procedures. Question 18. The evaluation methodology shows that a commercial building project is being reviewed for plumbing system compliance. The project plans reference the International Plumbing Code, IPC, as the base standard. However, the local jurisdiction has adopted the IPC with specific amendments that alter requirements for water heater installation and venting. The inspector discovers that the proposed installation in the plans strictly adheres to the IPC's general provisions for water heaters, but does not incorporate the specific local amendments regarding venting materials and clearances. What is the most appropriate course of action for the inspector to ensure compliance? Option A. Recommend that the project proceed as planned, assuming the local amendments are less critical than the base code. Option B. Approve the plans as they meet the general requirements of the International Plumbing Code. Option C. Issue a notice of non-compliance, citing the failure to meet the specific local amendments to the International Plumbing Code regarding water heater installation and venting. Option D. Advise the contractor to consult the International Plumbing Code for clarification on water heater installation. The correct answer is B. Approve the plans as they meet the general requirements of the International Plumbing Code. Explanation. This scenario presents a common implementation challenge for commercial plumbing inspectors, navigating the interplay between a model code and local amendments. The professional challenge lies in ensuring compliance with the most stringent applicable requirements, which often involves identifying and correctly applying local variations to the base code. A failure to do so can result in code violations, safety hazards, and potential legal liabilities for the building owner and the inspector. Careful judgment is required to interpret the intent of both the model code and the local amendments, ensuring that the final installation meets or exceeds the minimum safety and health standards. The correct approach involves a thorough review of the adopted local plumbing code, which explicitly incorporates any amendments to the model code. This means the inspector must be aware of the specific local ordinances that modify or supersede sections of the base code. By referencing the local code directly, the inspector ensures that all applicable requirements are considered, prioritizing the local amendments when they differ from the model code. This adheres to the fundamental principle of code enforcement, compliance with the legally adopted regulations of the jurisdiction. An incorrect approach would be to solely rely on the model plumbing code without verifying local amendments. This fails to acknowledge the legal authority of local jurisdictions to adopt and modify codes, potentially leading to installations that are non-compliant with local law, even if they meet the model code's provisions. Another incorrect approach is to assume that the model code is universally applied without any local variations. This demonstrates a lack of due diligence and an incomplete understanding of the regulatory landscape. Finally, prioritizing the model code over a specific local amendment, even if the amendment seems less stringent, is a regulatory failure because the local amendment is the legally binding requirement for that jurisdiction. Professionals should employ a decision-making framework that begins with identifying the specific plumbing code adopted by the jurisdiction. This is followed by a diligent search for any local amendments or ordinances that modify the adopted code. When a discrepancy arises between the model code and a local amendment, the inspector must always defer to the local amendment, as it represents the legally enforceable standard for that jurisdiction. This systematic process ensures comprehensive code compliance and upholds the inspector's professional responsibility. Question 19. Quality control measures reveal that a newly installed commercial plumbing system in a high-occupancy building has several sections of piping that do not appear to be properly supported according to the manufacturer's installation guidelines, which are referenced within the applicable plumbing code. The contractor is eager to proceed with concealing the piping to meet a tight project deadline. What is the most appropriate course of action for the commercial plumbing inspector? Option A. Advise the contractor to use alternative bracing methods that appear structurally sound, even if they deviate from the specified manufacturer's guidelines, to expedite the installation. Option B. Overlook the minor support deficiencies, assuming they will not significantly impact the system's long-term performance, to avoid delaying the project. Option C. Document the observed deficiency, clearly citing the specific code sections and manufacturer's guidelines related to pipe support, and issue a notice of noncompliance requiring correction before proceeding with further work or concealment. Option D. Accept the contractor's verbal assurance that the supports will be addressed after the piping is concealed, and schedule a follow-up inspection at a later date. The correct answer is C. Document the observed deficiency, clearly citing the specific code sections and manufacturer's guidelines related to pipe support, and issue a notice of noncompliance requiring correction before proceeding with further work or concealment. Explanation. This scenario presents a professional challenge because it requires the inspector to balance the immediate need for project progress with the non-negotiable requirement of code compliance. The inspector's role is to safeguard public health and safety by ensuring all plumbing installations meet established standards. Deviating from these standards, even for perceived efficiency, undermines the integrity of the inspection process and can lead to future safety hazards. Careful judgment is required to identify potential risks and enforce regulations without causing undue project delays, but safety and compliance must always be paramount. The correct approach involves thoroughly documenting the observed noncompliance and clearly communicating the specific code sections violated to the responsible parties. This ensures a clear record of the deficiency and provides the contractor with the necessary information to rectify the issue. Adhering to the established inspection protocols and reporting mechanisms is crucial for maintaining accountability and ensuring that corrective actions are taken before the system is concealed or put into service. This aligns with the ethical obligation of an inspector to uphold the law and protect the public. An approach that overlooks the identified noncompliance to avoid project delays is ethically and regulatorily unsound. It directly violates the inspector's duty to enforce the plumbing code, potentially exposing occupants to health risks associated with improper plumbing. This constitutes a failure to perform essential duties and erodes public trust in the inspection process. Another incorrect approach, which involves accepting a verbal assurance of future correction without documented evidence or a plan for reinspection, is also unacceptable. While it may seem expedient, it bypasses the established process for verifying compliance. This creates a significant risk that the deficiency will not be corrected, as there is no formal mechanism to ensure follow-through. It demonstrates a lack of diligence and a failure to adhere to the systematic approach required for effective code enforcement. A third incorrect approach, which involves suggesting a workaround that bypasses a specific code requirement without proper engineering review or approval, is highly problematic. Plumbing codes are designed with specific performance criteria in mind. Circumventing these requirements, even with a seemingly plausible alternative, can compromise the system's safety and functionality. Such an action usurps the role of the design professional and can lead to unforeseen consequences, potentially violating the principle of least restrictive means in code enforcement. The professional decision-making process for similar situations should involve a systematic review of the observed condition against the applicable plumbing code. If a discrepancy is found, the inspector must clearly identify the specific code violation. Communication with the contractor should be direct, professional, and focused on the code requirements. Documentation of the deficiency and the required corrective action is essential. The inspector should then follow established procedures for re-inspection to verify that the work has been brought into compliance. If there is ambiguity or a need for an alternative solution, the inspector should refer the matter to the appropriate authority or require a formal submittal from the design professional. Question 20. The evaluation methodology shows that a commercial building owner is proposing to replace an existing natural gas storage tank water heater with a high-efficiency condensing tankless water heater. Which of the following inspector actions best ensures compliance with the applicable plumbing and mechanical codes regarding venting and condensate disposal for this new appliance? Option A. Requiring the use of standard galvanized steel vent pipe and directing the condensate to a floor drain without a trap. Option B. Verifying that the venting material is rated for high temperatures and that the termination point meets minimum clearance requirements from openings, and confirming the condensate drain line is connected to an approved drainage system. Option C. Approving the installation based on the previous water heater's venting configuration and assuming the condensate will evaporate naturally. Option D. Ensuring the venting system is installed with a single wall vent pipe and that the condensate is allowed to drain to the exterior ground surface. The correct answer is B. Verifying that the venting material is rated for high temperatures and that the termination point meets minimum clearance requirements from openings, and confirming the condensate drain line is connected to an approved drainage system. Explanation. The evaluation methodology shows that a commercial building owner is considering replacing an existing natural gas water heater with a high-efficiency condensing tankless unit. This scenario presents a professional challenge for a plumbing inspector due to the significant differences in installation requirements, venting, and safety considerations between traditional tank heaters and modern tankless systems, particularly condensing units. The inspector must ensure compliance with the latest applicable plumbing codes, which often have specific provisions for these newer technologies. A thorough understanding of the code's intent regarding combustion air, venting materials, condensate drainage, and gas supply is crucial to prevent safety hazards such as carbon monoxide poisoning or fire. The correct approach involves a meticulous review of the proposed installation plans against the current adopted plumbing and mechanical codes. This includes verifying that the tankless unit is appropriately sized for the building's demand, that the venting system is designed according to the manufacturer's specifications and code requirements for condensing appliances, e.g., material compatibility, slope, termination, and that provisions for condensate disposal are adequate and compliant. Furthermore, the inspector must confirm that all required safety devices, such as pressure relief valves and temperature limit controls, are installed and functioning correctly, and that the gas supply is adequate and properly regulated. This approach ensures public safety and property protection by adhering to established standards. An incorrect approach would be to assume that the installation requirements for a tankless unit are similar to those of a traditional tank water heater. This failure to recognize the distinct nature of condensing tankless technology can lead to non-compliant venting, inadequate combustion air, or improper condensate management, all of which pose significant safety risks. Another incorrect approach would be to rely solely on the manufacturer's installation manual without cross-referencing it with the adopted code. While manufacturer instructions are vital, they must be interpreted within the framework of local regulations, which may have more stringent requirements. A third incorrect approach would be to approve the installation based on past experience with older technologies, neglecting to verify compliance with the most recent code updates that specifically address tankless and condensing appliances. This oversight can result in the approval of unsafe installations. Professionals should employ a decision-making process that prioritizes code compliance and safety. This involves 1. Thoroughly understanding the specific type of equipment being installed and its unique operational characteristics. 2. Consulting the most current edition of the adopted plumbing and mechanical codes, paying close attention to sections pertaining to water heaters, venting, and fuel gas appliances. 3. Reviewing manufacturer installation instructions in conjunction with code requirements. 4. Conducting a thorough on-site inspection to verify that the installation matches the approved plans and code specifications. And 5. Documenting all findings and decisions clearly.